Hi, and welcome to Module 7, Working with Languages. Here's what you'll learn about in this module. In the first section, you'll learn about some of the common issues with working with languages. In Section 2, you'll get an overview of tools you can use to detect and translate language. The third section reviews Amazon Transcribe and Amazon Polly and describes some of their common use cases. In the lab for this module, you will extract text from an audio file with Amazon Transcribe. You will then translate the text into another language with Amazon Translate and generate a new audio file in the new language with Amazon Polly. Okay, it's time to get started. At the end of this module, you should be able to describe the challenges of working with languages, identify the predominant language of a text with Amazon Comprehend, describe common use cases for Amazon Translate, Amazon Polly, and Amazon Transcribe. Implement a solution for transcribing and translating text. As you've seen throughout this course, working with languages is a hard problem for machine learning. One of the hardest aspects is that the meaning of words can change dramatically depending on context. The key factors your NLP application needs to understand in order to correctly extract context are: who is speaking? For example, is this a voice of authority? Is it an inquiry from a customer? What is the subject of the text? For example, is the text about a customer issue or a medical diagnosis? How does the speaker or writer feel about what they're saying? Sentiment analysis comes into play here also. Why do they feel that way? This is one of the most difficult aspects of extracting context. For example, if you detect that a movie review is negative, can you examine the text to discover why the viewer gave a negative review? Context analysis applies techniques to help answer some of these questions. You start your context analysis by determining the subject of the text. N-grams are a good way to identify the subject, as you can use them to find the most common groups of words in the text. Noun phrase extraction is another technique for determining the subject of a text. Noun phrases are a combination of nouns with another part of speech. For example, a noun plus an adjective, like hairy dog, or a noun plus a verb, like spinning top. While nouns and noun phrases are useful for understanding the subject and sentiment of a text, to fully grasp the context, you need to identify themes within a text. You can do this by using theme extraction. Theme extraction combines n-grams or noun phrases with a relevancy score to determine the most important themes in the text. One scoring system you can use is called lexical chaining. Lexical chaining ties noun phrases across multiple sentences to extract the key themes from a text. Thanks for watching. In the next video, you'll learn more about challenges for working with language. Hi, and welcome back. In this video, you will learn about challenges when working with languages. One of the biggest challenges you face with any NLP application is how to deal with various sentence structures. For example, syntax is not consistent for various languages. Some of the most obvious variations include word order. In English, adjectives generally precede the nouns they describe. This is not the case for many other languages, for example, Spanish. Expression of plurals or possession. Possession in English is often indicated by an apostrophe S. For many other languages, possession is indicated by including additional words. Expression of plurals is another factor that changes between languages. Whereas many English words create a plural by simply adding an S, other languages change multiple letters. In the Albanian example you see here, the IN changes to TE with an umlaut. Semantic analysis is the process of analyzing language to extract meaning from text. In order to extract meaning, semantic analysis combines the analysis based on language syntax with a layer that compares semantics across languages. These systems are known as semantic parsers. Developing a statistical model for understanding semantics requires a large dataset of validated translations in the source language. Assembling a dataset for less commonly spoken languages, known as low-resource languages, is a significant challenge for all NLP applications. Vocabulary is another challenge area for working with language. One estimate puts the number of English words in current usage at over 170,000. Other languages have similar word counts or even larger depending on the unit of measure. As you've seen in Module 4, one problem you may need to deal with for your NLP application is words that are not recognized by your working vocabulary. This is known as an out-of-vocabulary or OOV problem. Other challenges include homonyms. There are two different types of homonyms. First, you can encounter homographs, which are two words that are spelled the same but have different pronunciations and meanings, such as, I had to wind my way through the wind. The other form is a homophone, which are two words that sound the same but are spelled differently and also have different meanings, such as, I can only hear you when you are here. Another problem you may run into is false cognates. These are words that sound the same in two languages but have different meanings. For example, sensible in English means reasonable, whereas the word sensible in Spanish means sensitive. There are many examples of false cognates in languages derived from Latin. Finally, some languages such as Turkish and Finnish have very complex morphologies. Morphology in language describes how words are formed by changing either prefixes or suffixes. Both Turkish and Finnish have a relatively small number of base words, which are then turned into a larger vocabulary by adding prefixes and suffixes. While most NLP systems are based on evaluating words or phrases, the best solution to some of the issues you just learned about is to evaluate language at the individual character level. This approach, however, has its own set of problems. The vast array of character sets is a significant problem. For example, the International Organization for Standardization, or ISO, has defined standard encodings for 15 different types of encodings for various alphabets. The Chinese, Japanese, and Korean languages, also known as CJK characters, further complicate character processing. Non-standard spellings is another reason to employ character evaluation. For example, many countries where Arabic is the primary language, there are two different varieties of the language, one standard and one non-standard. This can make evaluating at the word or sentence level quite difficult. Character embedding is very similar to word embedding you learned about in Module 3. With character embedding, each letter in a word is assigned a vector. The model produced by these vectors is then trained to group similar vectors. Here are some common use cases for applying machine learning to language. Using machines to translate between human languages has been a major problem in computer science for many years. In fact, machine translation was one of the earliest goals of computing. Recent advances have made it possible to have real-time translation in some of the most commonly spoken languages. Converting spoken language to a written form has many applications, from medical records to legal or other business settings. Creating subtitles for movies and videos has been greatly streamlined by the advent of machine learning-based transcription services. And finally, the explosion of text-based interactions in recent years has created a major opportunity for business to learn more about their customers as well as their own operations. Capturing and analyzing text is being used for analyzing customer support requests, reviewing and categorizing medical diagnosis, and many other text-based records. In this section, you looked at some of the challenges for working with language. These challenges include problems with understanding context, the wide variety of language structures, and problems resulting from large vocabularies and differences in syntax, and low-resource languages. Finally, you also looked at some of the more common use cases for transcription, translation, and text and voice applications. Thanks for watching. In the next video, you'll learn about two different approaches to machine translation. Hi, and welcome back. In this video, you will learn how to detect the language of a text and about machine translation. You've already learned about several use cases for Amazon Comprehend in this course. You can also use it to detect the language of a text. Amazon Comprehend uses a pre-trained model and can detect 100 different languages. When Amazon Comprehend returns the detected language, It also returns a confidence score for the selection. In addition to Amazon Comprehend, there are several Python packages you can use to detect the language of a text. LangDetect, Spacy, and FastText all include libraries you can call to detect a language. Here you have a screenshot from the Amazon Comprehend console showing language detection. The code snippet shows how you can use the LangDetect Python package to detect language. Amazon Translate is a neural machine translation, or NMT, system. The system uses a pre-trained model and can detect 100 different languages. The slide shows an example of language detection in the Amazon Translate console. You can also generate translations by using the AWS Command Line Interface, or AWS CLI, or the Application Programming Interface, or API. There are two approaches to machine translations: statistical machine translation, or SMT, and neural machine translation, or NMT. SMT starts by creating a model of a source language that is based on a very large set of previously translated documents. Once you have the model, you can then apply it to new texts in the source language to predict the translation in the target language. These predictions are based on probability theory. SMT is based on translations of individual words and phrases. The SMT system builds a translation table which lists the frequency of word combinations in the source language collection. Phrase translation with a higher frequency in the source collection have a greater probability of being correctly translated than those with a lower frequency. There are several problems with SMT systems. First, they're not well suited for understanding the influence of context on meaning. Also, the accuracy of the translation depends on language pairs. For example, English and Spanish might work better than English and Mandarin. Finally, SMT systems do not work well with languages that have dramatic differences in word order and sentence length. NMT systems use neural networks to learn a model based on previous translations. As you learned about in Module 2, neural networks include two sets of nodes, one for an encoder layer and one for a decoder layer. Most NMT systems are built with recurrent neural networks. NMT systems are better at understanding context than SMT systems, as they can capture the context in a vector and then apply that vector to multiple language pairs. NMT systems are generally an improvement on SMT systems, which were developed before neural networks were in wide-scale commercial use. There are, however, still several challenges. Long sequences of text, for example, very long sentences, can cause the network to forget the earlier part of the sequence. This can be mitigated by introducing an attention layer, which was discussed in Module 2. Next, large or specialized vocabularies are still a problem for NMT. NMT systems are resource intensive and require long training times. And finally, NMT systems still struggle to provide translations for low resource languages. In this section, you looked at tools for detecting and translating language. You also learned about two different methods for translating text: statistical machine translation and neural machine translation. Thanks for watching. In the next video, you'll learn about two different Amazon services you can use when working with language. Hi, and welcome back. In this video, you will learn about two Amazon services for working with language. You can use Amazon Transcribe to convert spoken language into text. You store the audio files in S3 and then either invoke a transcribe job from the AWS console or in a script with the AWS CLI. You can also create real-time transcripts by sending streaming data to Amazon Transcribe. Amazon Transcribe supports two different protocols for streaming data: WebSockets and HTTP2. Amazon Transcribe returns text as JavaScript object notation, or JSON, files. These files contain metadata about the audio, such as start and end time, as well as speaker identification if there's more than one voice. Amazon Transcribe can also create transcripts from multiple audio channels. If you have multiple channels, Amazon Transcribe creates separate transcriptions for each channel and then combines them into a single JSON file. Here are just a few example use cases for Amazon Transcribe. You can generate text messages based on audio files. You can also create a written transcript from spoken records of medical or legal experts. Call center records can be stored in S3, then analyzed by exporting the transcript output. Finally, you can use Amazon Transcribe to create a real-time translation engine by integrating with the service with Amazon Comprehend and Amazon Translate. With Amazon Polly, you can convert text to audio for a variety of applications. You can either copy and paste into the AWS console or read text files from S3 for batch processing of longer texts. You can also customize voices by selecting from a variety of speaking styles. For example, there are multiple English-speaking voices. In addition to the standard voices, you can select one of the Neural Text-to-Speech, or TTS voices. These voices are generated using a sequence-to-sequence network and have a more natural sound. You can add custom lexicons to support specialized vocabularies and control speech patterns by adding SSML tags. For example, you can add an emphasis tag for words or phrases you want the voice to stress. You can also pause speaking and control volume, speaking rate, and pitch. You can control Amazon Polly output by adding SSML tags to the text. The break tag adds a pause in the speech. You can specify the length of the pause by adding a number of seconds, or you can add preset values such as weak or strong. You can find the complete list of SSML tags in the Amazon Polly documentation. If you're coordinating your speech output with visual output, you can have Amazon Polly insert speech marks. Speech marks are metadata that specify when the sounds in the audio output begin and end. For example, you might have Amazon Polly export speech marks for every sentence or word in an audio file. You could then use these speech marks to synchronize the output with animation or to dub a live-action video. The text files that you're working with might contain a large quantity of specialized vocabulary. In this case, you can create a custom lexicon that instructs Amazon Polly how to pronounce these specialized words. Here are just a few examples of how you can use Amazon Polly to add voices to your applications. You can make websites more accessible by adding voices. With Amazon Polly, you can add speech to animations for e-learning assets. Customers have improved contact center interfaces with voice response. And finally, you can make alerting systems more accessible by adding a voice option to text notifications. In this section, you reviewed the features and learned about several use cases for Amazon Transcribe and Amazon Polly. Thanks for watching. In the next video, you'll wrap up the Academy NLP course.
Welcome back. Let's wrap up the AWS Academy NLP course. In this module, you'll review what you learned in the course. You'll also get some information about next steps for working toward AWS certification in machine learning. Let's start by reviewing what you learned during the course. In this course, you learned how to describe the natural language processing, or NLP ecosystem, identify how NLP can be used in business, indicate the range of problems, tasks, and solutions addressed by NLP, and describe how to apply the ML pipeline to NLP. You also learned how to use the ML pipeline to solve NLP problems. You can now describe the evolution of NLP architectures, evaluate ML algorithms for sentiment analysis, and create a solution for a sentiment analysis business problem. Finally, you now know how to explain the use and purpose of Amazon Translate, Amazon Transcribe, Amazon Comprehend, and Amazon Polly. Let's take a look at one way you can extend your knowledge: achieving the AWS Certified Machine Learning Specialty Certification. AWS certification helps you build credibility and confidence by validating your cloud expertise with an industry-recognized credential. It also helps organizations identify skilled professionals who can lead cloud initiatives by using AWS. To earn an AWS certification, you must earn a passing score by taking a proctored exam. After receiving a passing score, you'll receive your certification credentials. AWS certification doesn't publish a list of all services or features that a certification exam covers. However, there's an exam guide for each exam, and it lists the current topic areas and objectives for the exam. You can find the exam guides on the AWS website. Note that you're required to update your certification or recertify every 3 years. You can get more details about recertification on the AWS website. The information on this slide is current as of June 2020. However, exams are frequently updated. Also, the details regarding which exams are available and what topics are tested by each exam are subject to change. The AWS Certified Machine Learning specialty means you can select and justify the appropriate ML approach for a given business problem. You can also identify appropriate AWS services to implement ML solutions. And finally, you can design and implement scalable, cost-optimized, reliable, and secure ML solutions. Before taking the AWS Certified Machine Learning Specialty exam, we recommend that you have the following knowledge and experience. First, you should have 1 to 2 years of experience developing, architecting, or running ML or deep learning workloads on the AWS cloud. Your experience should include performing basic hyperparameter optimization and working with ML and deep learning frameworks. You should also be able to express the intuition behind basic ML algorithms. Finally, you should be able to follow the best practices for model training, deployment, and operations. Thanks for watching, and congratulations on completing the AWS Academy Natural Language Processing course.